Okay, so composite functions, and then we'll go over some polynomial rules at the end. But here are two of our functions. The function f at x is equal to x squared minus 3. The function g at x is equal to negative 6x plus 5. So since they're equivalent, instead of writing out the long form of the function with the variables, coefficients, and constants, I can actually just use these symbols to express different functions. And a composite function is the idea of a function within itself. So we have some symbolism here, or f, g, and using the variable x. And then we could talk about the opposite of such a function, functions g and f using the variable x, and what they're equivalent to. So with this information, sometimes it's a little easier, symbol-wise it's not so easy to see, but to rewrite a function kind of like this. What this is saying is we're looking at function g at x, okay? And it's going to be within the f at x function. We'll be replacing that x function. So sometimes the symbolism is written like this, f at g at x. Sometimes they write like this. With all those brackets, it can be a little confusing here. Essentially what's happening is we're taking that g at x function, okay, so which is our negative 6x plus 5. So I'm going to focus on just the inside of this f at x function. Okay, so let's kind of say that the f is still on the outside, but within it we're using g at x. So g at x is negative 6x plus 5. Okay, so we have that part, but what's the function f? Well, the function f is this other part. So I'm going to write it below, and then I'm going to show you how it kind of substitutes in. X squared minus 3. X squared minus 3. So think of this now like this. Instead of f at x, x is the variable within here, I've replaced that f at x. That x value is now this, negative 6x plus 5. So I've taken this part and plugged it into the x here. So the function can now technically be written as negative 6x plus 5, right? And if that's the case, well, I'm just replacing the x in this function with that negative 6x plus 5. I replaced that x within the function, so negative 6x plus 5. And now that this x has been replaced, I just use the rest of the function the same as it was. So this would be squared, and this is minus 3. So they write it this way so that it's not so convoluted to write it out this way. It's very long. So they use this symbolism to represent those ideas so they don't have to write out all of these. And then this is a function itself. What is this actually equal to? Well, we can simplify what we have here. We can use our distributive property. And again, I'm not going to write it out this way. I'm going to say f at g at x, okay, is equal to, and we've already put this part out, so now we can go negative 6 plus 5 times negative 6x plus 5 minus 3, so we'll kind of work through this. 2 negative 6 is just 36x squared. Negative 30x, yeah, negative 60x plus 25 minus 3 is going to be 22. There you go. So your function, or your f at x function with g at x within it is equal to this standard form of a quadratic. What about the opposite? The function of g at x and f at x. Okay, well that's the same as writing g at f at x. So the f at x function is within the g at x function. Well, what are those functions again? So we need to write them out. The f at x function we said was x squared minus 3. So I'm going to get that extra bracket there. So that's why the symbolism is a little tough sometimes. The f at x function, we'll write it within, is x squared minus 3. Okay, so we've just replaced f at x with the f at x up here, which is the equivalent of that, right? We used this part to replace the f at x function within this bracket. So we replaced f at x with that. And, well, what's g at x? Well, g at x, okay, we can rewrite it this way if we like, x squared minus 3 is equal to, so we're replacing the x part of the g at x function. Well, the g at x function was 6x plus, or negative 6x plus 5. So the negative 6 stays, that's the coefficient. It's the only thing that changes is the variable. And the variable is no longer x. The variable is now x squared minus 3. So it's just taking the place of that x variable. It's negative 6x, and then plus 5, the constant stays. And same idea, again, we're not going to use this I'm going to write that g at f at x within it, so it's a little easier to look at. And we just kind of collect like terms. We simplify our equation. So we now have negative 6x squared plus 18 plus another 5 is positive 23. Okay, so depending on the order that it's written is f.g or g.f, we get very different functions. Okay, so we just have to be aware that all we're doing is replacing a variable in one function with the entire other function. Okay, some rules. I said we were going to talk about a rule or two here, so let's look at a rule or two. Bring that up.